I'm going to say one of the realest things I've ever really noticed and said, okay? The internet is not the most powerful computer. It is not the most powerful program in the entire computer. It is not. The internet is just a single program. And a lot of people get lost in the internet. The most powerful program on a computer. I know you like my new Mac, and I will say this. This is my first time ever using a Macintosh, especially my own. All right, so I do have a Macintosh, and this is on my Windows machine. It is possible to get a brand new Macintosh on Windows. I hadn't paid a dime for this. And I was going to run a few commands. We're working in the cloud computing and stuff like that. I'm going to see if I can yeah, I guess I don't have to. There it is. Yeah, I was just fooling around with some program. Yeah, that was nothing easy. I could probably clean it up though. I can make it much better. So this is the most powerful program on the internet. It is simply the command shell. All right. In this case, in every Macintosh has the command shell, and that's what makes Apple so appealing and so powerful. I know this looks a little corny because, like, compared to my monitor, this doesn't really even fit my screen. So it's a little frustrating to see my Mac so small, but it's just because my monitor is so big. And I have two monitors, so when I move this program to the other monitor, it fills it up perfectly. It's the perfect size. So this is definitely by far the most powerful program on the computer. The reason is because it allows you to create programs, talk to the computer, go inside the computer, dig inside the file systems and do things automatically. And this is a program in itself. It's a program running right now, and it does commands, it carries operations, you can create codes. Very, very powerful program. So you get to know Bash, Linux. There's a lot of good books out on there. Get to know your command prompt. That's the first step in learning how to operate your computer. There's a lot to the computer that a lot of people won't ever tell you. So get to know your command prompt. And at some point I'll show you, okay, how can you get an Apple computer on your Windows machine. I have Windows. Let me pull it up again. You don't believe me? I can minimize this window. This is just, it's fake. It's not even, it's not fake, but the reason why I had to do this, I had to run my Mac, a new Mac. I had to basically run it, spin up a new Mac. Was because I was building an app, an Apple app for one of my websites, and you need a Macintosh in order to build an Apple Mac, in order to create a little app for Apple. You need a Mac. Okay, so that's why I did this. But yeah, no, this is legit. I mean, It's good. I've have some quite a bit of memory stored in it. I don't know what's gonna come up. But this isn't why I'm making a video though. Um, in fact, let me exit. Hopefully this should clear it out. So the last time I logged on, um, to this thing, I had to update it, and it automatically shut down on me. So now it looks like it's remembering that. In fact, let me make this bigger. And so I don't even know how to run a Mac. I really don't. Now, whenever you want to test it out, if your internet is working, go to some store, and if it's working, it's gonna run for the store because they think you're about to buy something. So if you just act like you're about to buy something, that's a good way to test out if your internet is working. Okay. I'll come back to this. Maybe I can go over some important commands in the terminal, some things you should get to know. There's everything in there, literally everything. In fact, I'll show you another one that I work off of. Sometimes I don't go into Mac to work off the command prompt, although I could, and that'd be a great idea. This computer is not set up for that. I'm going to need a new data science computer that I'm going to have to build soon. And I live right across the street from a computer store. But they're a little overpriced, but they do have good like knickknacks and used stuff and all that good stuff. So I actually should just buy some stuff. They have some cool towers that they're like imitated off the high-end type, but they're really cheap, like 70, 80 bucks. But when I built my data science computer, I said I'm gonna need about 6 screens, 6 monitors, 3 stacked on top of each other. So 2 rows of 3, 1, 2, 3, 1, 2, 3, and have multiple hard drives, GPUs, CPUs, the whole 9, 64-bit RAM, everything, external, internal drives. Then when it's time for me to run a program like this, I can run it without any too much difficulty. Let me close this out. I honestly don't even know what to do with this Mac. I really don't know. I know it signed into my phone, which was kind of neat. But honestly, it's just interesting that that you can have a Mac on a Windows. So if someone ever says, hey, it's impossible to have a Mac on a Windows, you know, talk to D. Thomas. You can get it for free in about 10 to 15 minutes. And honestly, if I go into my file system, well, it just kind of shows more apps and things of nature that I already have. Nothing major. Oh, a chess app? I didn't know there was a chess app. Well, maybe I did know. I shouldn't play chess on this because I got things to do. You know, chess is a great time when you're waiting for a certain time. It's the best way to kill time is to play chess. This computer is probably pretty strong too. I can test it out. Let me see. It's having issues loading. I think I'm running. Oh wait, because I pulled up iTunes. Yeah. As you can see, I don't have much RAM. Cancel.
On E7 to E6.
And yeah, I'm not gonna do this now. I play enough chess. Let me get back to my simulator. And he actually knew mine. No, thank you. Okay. I may have to just close out my Mac. I don't even know how to shut it down. Yeah, I might as well just shut it down. I'm not going to do much on there. I'll show you some other commands on the command prompt. We'll come back to this in another video. I'm going to start posting some more. I have an interview at Microsoft, and it's related to building bots. And, you know, I'm still contemplating whether or not I want to do it. Just because I'm working on my own business, you know, and although it's just kind of being a support person and make it about $50 an hour, I'm just not sure if it's as much security as I would like. So there's one of my simulators, and it's set for some randomness. So let me look back at my code. Let me create my window. I'm gonna chop my window down a bit. Let's make it 750 and 6. A little bit more wider. Yeah, 5. So the gravity is good, and because you see how it's falling to the right, and that's because the y coordinate is set to be a little bit more. The x coordinate is going to be a little bit more than the y coordinate, and right now these are random values. The width is 750, so from 100 to 650, any random number, and then the y is not as random. But if I change the gravity and the damper to just 1, so basically it's not a factor at all, friction may not even play a part. It's going to go on for quite a while. And they kind of gravitate towards that right wall, and they don't bounce off, which is freaking me out. And it's all because of this random mechanism, because if they were the same, I think something weird's gonna happen. So all 20 particles will be 50 radians. The speed. Oh, so this is actually where they're starting. The speed is in here. Okay, now we're talking. So if I increase that, well, I want the collision to be once the X should change direction. This guy is not coming back down. It's really odd. Not even a little bit. Stroke weight, number of size, let's make it hexagons this time. The radius, set X, Y, Y1, speed, gravity, I'm going to comment that out, and I'm going to comment this out. Oh my god, yo. Oh wait, this is in there twice. That's why. So now, yes, yes, yes. Okay. Okay, this is the effect I wanted to get. Whereas this collision code took me a while to figure that out. Man. I'm just getting chaos now. And I can go back to my having the damper and the yeah, that was weird. I didn't even see that, man. That was there the whole time. So it was being negated. I think we're just gonna start at 0, 0 and see what happens. Let's add one. Oh, it has to be more than the radius. And that's because of the code of the check collision is set for if it's less than the radius, then it hits off the other side, and it kept getting stuck. I wouldn't have coded it that way, but it's fine. I'm using this function of the check collision function, and the polygon code is in here. The polygon code is pretty cool. We got our stroke, rotation amount. Although we probably could make it a curved vertex. Let's see what happens this time. That's not what I wanted, but it's fine. Let me go back and fix that. So any random number between 100 and half, and I'll do width divided by 2 is on the x coordinate, and then the y coordinate could be 60. But what if I make it a sign 2 times, to make it even, 2 times I plus, well, there's 20 and we're going 750. Let's make that 800. And we're doing 2 times that plus, say, 100. That wasn't much, is it? So we have 0, 152, 250. It's apart. And then so if we were to set the speed to be correct as well, about the same, 4 and 4. Well, then we wouldn't be able to see them. They're all going to be on top of each other. Oh, wait, no. We're spread out. Same speed. I took off the gravity. Okay, this looks good. So now the speed is, we took that off. Well, gravity's set to 1, so it's okay. I guess that makes it fall better. So here we go. Let's play this. I think we can go 200. So there's 800, but the radius is 50. There's 20. This has to be a little smaller. Let's go by 100. Oh wow. Some of them must be on top of each other because Okay, so let's drop the particle count and let's make this window 8 by 500. All right, this is actually getting pretty boring. um, let's do some pentagons, and we'll make them, in fact, not too good the colors. I can just choose a random color. Let's, I don't know what that's gonna do. Whoa. It's too spread out. And then what we'll do is do another one of these guys. So with the pentagons, but on top of the pentagons, we can have some circles, you know, some squares with a different color. So now they're all interconnected. But let's make our gravity this, or put our damper at that. And our friction, of course, we don't want it to slide too much. Let's increase, let's change the, let's let the X goes a little faster. That was interesting. We're getting there. We're getting there. That was kind of uneventful. It's nice how it's kind of integrated in there. I should try to integrate one of my codes that I have with this circular object. It's pretty interesting though. So yeah, no, the code was pretty straightforward. We changed everything to floats, to arrays. We defined the array to be a float array. The name is X, and then we filled it with this new set of particle count. So 10, the size of the array is 10. It can accept 10 floats, all of the same size. And the size of each array can change based on the number of particles. And so this code operates 10 times for each object. But I guess it's probably better to get back to the randomness of the speed, radius, and where it takes off from. And this is the code to actually create the shape. Here's the speed. And then the check collision function, if it touches the wall, it's supposed to bounce back. And here it is. Here's the function check collision. That's about it. The polygon function is here. Uses some trigonometry though. It's pretty interesting. Polar coordinates. We converted the polar coordinates into the rectangular. That was pretty interesting. We should do a spiral though. There's a code for a spiral. I was forgetting it. I know it's r equals theta. And then x is r sine theta, y is x is r cosine theta, y is r sine theta. So I'm thinking if we had theta in terms of r, so it'd be let me see, maybe I can do this. But we're going to call this spiral. This is a different beast, because we're going to do 100 times pi. Actually, I don't even know. I shouldn't even have done that. Stroke this, no fill, begin shape. So it'd be. So the spiral is r equals theta, but in rectangular coordinates that'd be x over sine theta equals theta, and y over sine theta equals theta, which is just theta sine theta. X is theta sine theta. It'd have to start. And this time we would need the curved vertex. And I should call these not x2, let's use Is there x1 anywhere? So it'd be x1. Theta, cosine theta. And let's let radius be 1. I don't even want to mess around with the radius. We'll let the radius be 1. And theta would increase. Okay, so I guess we could do, it could be quarter of a pi. So then theta would be equal to theta plus and there should be only, it seems like there's only Fock stroke. Stroke color, stroke weight. Okay. This is different. This has to do it a lot of times. I mean, this has to go 360 times some large number. No fill, stroke, I don't even know if I spelled it right. Spy, roll, and then the stroke color. it just does it immediately. And it is slowing the code up. So I wanted it to start Alright guys, I'm gonna wrap it up here. I'm gonna work on my oh wait. It's getting this. Oh no. Okay, I took out the radius. Oh, that's pretty wicked. So, oh no. Okay, so I can start with 0, 0 now. It wasn't it. That's fine. So now there'll just be 1. Of course. It's really interesting. Design is doing that. Want it to go all the way around, but not like that. We'll keep working at it, guys. I gotta get into some chatbots. Gotta get ready for this Microsoft interview. Oh, I should stream that though, because it helps. It helps when you study together. When you work with somebody, one of the highest forms of learning and teaching is actually teaching. So whenever you want to learn something and you're doing something for the first time, it's important that you must teach it. You must teach it and share and teach. That's very important. So that's going to do it for now, guys. I'm going to wrap it up. Just put in some time. I never really made the shape before. I was just kind of fooling around with it, and it looked like it kind of did it. But to actually change how much I wanted to do, I'd have to go inside the theta here. Like if I wanted to, like let's say if I did 5 and 5 times, and another 5 times. It's gonna change the. It's gonna change it. And you know, it also because I'm using the curve vertex. I mean, if I I took that away, just did the vertex one, that might be a little bit more interesting. Oh yeah, some wicked spider web. I like that. Yeah, that's crazy, man. We get some lines just like going outside of it like that. But yeah, no, that's pretty interesting. We're gonna keep at it, man. We're not done yet. We're gonna keep at it. So for now, D Tommy is back in business. He's getting stronger in this technology game. I mean, watch out. Watch out. When you get stronger, there's nobody can stop you. You know what I mean? We're doing Java, Spiral, polygons, whatever you name it, man. We're doing it. And in fact, I'm gonna. Is there a way to? I can. I'll just comment this code out, as well as that. That color didn't really do anything. I still remember that. That was this. This just looked like grayish, maybe, or kind of white. We're getting sharp, boy. Boy's getting sharp, man. Damn. We getting sharp. I'll show you one of my other projects I just recently did, man. Let's see if I can pull it up over here. I'll show you one of my. And this is like, yo, you don't need nobody else to do your logo. Like, Cats is doing their own logos and stuff now. This was one, but I don't even know. Like, I just put a picture of myself, but nah. Here's another one though. I'm not even gonna mess with it. Here's one. I redid this painting here. I'll show everybody. I redid this painting. So this is what the painting looked like. And I recoded the entire painting. It took me a couple days to do it. It was a lot of work. Redid it. This. So that was it. I mean, I thought that was pretty. Man, watch, I'm gonna do something. They're gonna be like, "Oh my god, he really gets it now." I'm just chilling right now, man. I'm pacing myself. As soon as I catch everybody slipping, I'm gonna strike. Be hungry, man. It's like it's like the Olympics, you know, but it ain't no gold medals. And we going hard, man. Peace out, guys. It's from Washington State, D Tommy.